Hello all. Today we are solving LeetCode problem number 1266, minimum time visiting all points. So basically we are given a list of points on a 2D matrix and we start from the first point in the given array and we visit all the points in the order basically, and the movement moves which you are allowed to move in the grid, or you can move left and you can move right, you can move up, you can move down and diagonal, and each of these all moves cost us 1 second time, right? So we have to find minimum time needed to visit all the points together. So in the example you can see you are given a point array basically. So let me change the color of the marker, right? So you are given a points array basically and you have three coordinates basically, right? So you start from this particular coordinate and you have to stop at this particular coordinate, and you have to move from this coordinate to this coordinate and from here to here. So this is how you have to follow the order, and you have to find the minimum time needed to move from 1 1 to negative 1 0, right? So before understanding this and coming up with this idea or approach or of how to solve this, we have to understand what is it to move in a grid like, right? So let us consider a grid, right? And let me consider a point. So I can mark this 1, this will be 0 0, and this 2, and let this be 1 and this be 2 for now, right? So let me have a point which is 1 1. Let me expand this, right? Let me have this point 1 1. So if you are moving left, we will end up here, which is 0 1. Okay, so if you are moving right, right, this side, so we will end up here, which is 2 1. And if we are moving up, we will be here, which is, this is 1 2, right? And if you're moving down, which it will be 0, oops, or this will be 1 0, right? And if you're moving diagonal, I think it's a bit confusing. So if you're moving diagonal, you will end up here in 2 2 basically. So let me erase down everything and you can see diagonal alone for now, right? So this is how the is meant, like what exactly move in a grid mean, like, right? So now we have to navigate from one point in a grid to the other point in a grid. So let us see that in this example, right? So in the let me mark down the points given. So this is 1 1, and this is 3 4, and this is negative 1 0, right? So we have to start from this point and we have to go here, then we from here to here. So we have to calculate the minimum distance, sorry, it's not a minimum distance, it's a minimum time consumed from navigating from 1 1 to negative 1 0. So navigating means first we have to move from 1 1 to 3 4. So what are all the possibilities? We can move this, we can have a upward movement and one more upward movement and one more, and then right and then right, so which costs 5. Similarly we can move right right and up up up, which also will consume 5, right? So is there any better movement you can moves you can see in this grid, right? So here there is a better move, right? So based on this, let me erase this all quick. So we already took 5 seconds to move from 1 1 to 3 4, right? So based on this, there is a diagonal move which is 1 1, and there is a upward movement which is 1. So it takes 3 moves, so which is the minimum one. So this is the move which we have to take in consideration for calculating the minimum moves from navigating from a point to the next point, right? So based on this, we have a formula to calculate the minimum time, right? So the formula is we have to we are given x1 and y1 as one coordinate where we start, and we have x2 y2 as the other coordinate. So from moving from x1 y1 to x2 y2, the minimum time formula is maximum of absolute value of x2 minus x1 and absolute value of y2 minus y1, right? So maximum of these will be the minimum amount of time taken from moving from this point, this particular point to this point, right? So if we have in this list we have 3 points, right? So in that case we will start from 1 1, we have to move to 3 4, and we have to find the minimum distance, minimum time, minimum time, and from 3 4 to minus 1 0, again we have to find the minimum time, sum this up, return the answer, right? So let me solve this first, and then based on this we can go ahead and code this up, right? So from 1 1 to 3 4, this will be the first iteration. So we are taking points of I and points of I plus 1, just to have this in a mind, so that this will be very helpful while we are coding this up, right? So based on this, x1 minus x2, absolute value of x2, sorry, 3 minus 1, and absolute value of 4 minus 1, which is maximum of 2 and 3, which is 3, right? And next one, 3 4 and negative 1 0, right? So in this case it's negative 1 x1 and x2, right? So negative 1 minus 3, absolute value of it, and absolute value of 0 minus 3, which is maximum of, this is 4 and this is 3, right? Am I doing this correct? Oops, this is 4 and this is 4, sorry. Yeah, so maximum of 4 and 4 will be 4, and now we have to sum this up. 1 plus 2 equation, this gives 7, which is the output we are getting in this answer, right? So this is how we will be solving this problem, and the time complexity will be order of n, since we are performing only linear iteration here. So yeah, so let us go ahead and code this up. Yeah, so let me write down the time complexity as big O of n, and we need to have a variable for returning the value, right? So min time is equal to 0, and now we have to iterate through the loop. So for in range len of points, and since we are taking points of I plus 1, this should run up to the length of points minus 1 time, right? So now we have to get the value and store that in the variable x1 and y1. So x1 and y1 is equal to points of I, and x2 y2 is equal to points of I plus 1, right? And now we have to find the absolute value for getting the minimum moves, right? So tx is equal to absolute value function of x2 minus x1, and ty is equal to absolute value of y2 minus y1. And now min time plus or equal to maximum of tx comma ty, right? And now return min time. Yeah, so let us go ahead and submit this up. And yeah, thank you.